We're on lesson 9 of chapter 10, which is the probability of compound events. First, we're going to find the probability of combinations. Then we're going to find the probability of permutations. Then we're going to find the probability of other compound events. So just a reminder, we've worked with combinations in previous lessons, permutations in previous lessons, and then also other events too, which involve tables, lists, or just counting. So when you need to find the total amount of combinations, you can either make a list, or you can use the formula that we've used with factorials. And when you get your total amount of combinations, that becomes, in your theoretical probability, the total number of equally likely outcomes. Then on top of your theoretical probability is the number of ways that the event can occur. It's an event that you're looking for. Permutations works the same way. When the order doesn't matter, you can find the total number of permutations by either making a list or using a factorial. When you find the total amount of permutations, that is the total number of outcomes. Then you can use the ones that you're looking for to go on top to find the probability. Other events, you can find the total number of outcomes by doing these things. That is the bottom part, and then the top part will be the total number of ways the event can occur. Let's give it a shot with a few examples. First, let's look at the combinations one. It says a pizza parlor offers 6 different pizza toppings: anchovies, mushrooms, olives, onions, pepperoni, and sausage. What is the probability that a random order for a 2-topping pizza will be mushroom and sausage? Well, first we need to find the total number of equally likely outcomes, meaning we need to find all the different possible combinations that we could have, which would go on the bottom here. Well, if we go back to our formula, remember we have n factorial over n minus k factorial times k. You can pause this if you didn't watch last lesson. So n is the total number to choose from, and k is the size of your group. So size would be 2 of a group. So it would be 6 for your factorial over 6 minus 2 factorial times 2 factorial. So if we rewrite this, it's 6 times 5 times 4 times 3 times 2 times 1. And that would be over 6 minus 2 is 4, so the factorial of 4. 4 times 3 times 2 times 1. And we're multiplying that times the factorial of 2, so times 2 times 1. So on top, this multiplies to 720. On bottom, that gives us 48. 720 over 48 gives us a total of 15 combinations. So that would be the total number of equally likely outcomes. You have 15 total outcomes of combinations that you could have. We're only looking for one. We're only looking for mushroom and sausage. So we're only looking for one combination. So if you're making combinations of pizza toppings, the chances that you would have mushroom and sausage as your combination from these 6 different toppings would be 1 out of 15 probability. So just to recap, we found the combinations using the formula. We plug that into the denominator, which is the total number. The number of ways that our event could occur was only 1, so it would be 1 over 15. Let's try this one then. A pizza parlor offers 7 different pizza toppings: pineapple, mushrooms, Canadian bacon, onions, pepperoni, beef, and sausage. What is the probability that a random order of a 2-topping pizza includes pepperoni? Well, if we're doing our formula again to find combinations, remember it's the total number that you can choose from, so that's 7. So we have 7 factorial on top. Then in here we have 7 minus the total in the group, which would be a 2-topping order again, so 7 minus 2 factorial times 2 factorial. So if that gets written out, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And that would be over. 7 minus 2 is 5, so it would be 5 factorial times a 2 factorial. On top we have 5,040. On the bottom we have 240. So our total number of combinations, if we divide, would be 21 combinations. So we found the total number, that would be the bottom of our theoretical probability. So over 21. Now the number of ways that our event can occur. We're looking for any 2-topping pizza that includes pepperoni. So you could have pepperoni and pineapple. You could have pepperoni and mushrooms, pepperoni and Canadian bacon, pepperoni and onions. Pepperoni and pepperoni would be not a combination. Pepperoni and beef, and pepperoni and sausage. I see a total number of 6 events that could occur our way, or 6 combinations that would fit. So 6 out of 21, if we simplify that by dividing both by 3, that would give us 2 out of 7 chance that your random order will include pepperoni. Now we can find the probability of permutations. It says Bonnie, Karina, and Deanne line up in random order for softball batting practice. What is the probability that the girls will line up from front to back in alphabetical order? Well, we're finding a permutation here, so order matters. So if you're finding the total number of equally likely outcomes, let's find the permutations of 3 people in order. Well, for that first person in line, that could be all 3 of them. It could be either one of these people to line up first. Now we're looking for the second person in line. If there's already one person lined up, that leaves 2 people left to line up. Now that we're looking for that third person, we're left with 1 person. So 3 times 2 times 1, that equals 6. So there's 6 permutations. That is the total number of equally likely outcomes. So that goes on the bottom. Front to back in alphabetical order, that would be Bonnie, then Karina, then Deanne. There's only one way that that can happen, so that would only be 1. And here's our theoretical probability of this happening. Now we have Jack, Kate, and Linda line up in random order at the cafeteria. What is the probability that Kate randomly lines up in the middle between Jack and Linda? So just like this last one, we're looking for a permutation of 3 people in any order. Any of them could line up first. 2 of them could line up second after that. And then only 1 person can line up third after that. So that gives us a total of 6 permutations again. So that goes on the bottom. That's the total number of outcomes that we could have. So now let's think about it this way. Kate could be in the middle if Jack was first. It could be Jack, Kate, Linda. It could also be Linda, Kate, Jack. Either way, Kate is in the middle. So that means that there's 2 total possibilities with Kate in the middle, meaning that our total number of ways that it could occur would be 2. So we have 2 over 6, which would be 1/3. Another way of looking at this, if you want to use your common sense, there are 3 people. So what is the chance that Kate is the middle person? It would be a 1 in 3 chance that Kate is the middle person. It would be a 1 in 3 chance that she would be the middle person, 1 in 3 that Linda would be, or a 1 in 3 that Jack would be. Now let's find the probability of other compound events. It says Jen rolls 2 number cubes. What is the probability that the sum of the 2 numbers will equal 5? So we can make the columns our first roll of the number cube, and then the rows the second roll. So number cube could be 1, 2, 3, 4, 5, or 6. And the second one could be 1, 2, 3, 4, 5, and 6. So we're looking for the sum of these number cubes. So if the first one was a 1 and the second one was a 1, that would be 1 plus 1, which would be 2. 2 plus 1 would be 3. 3 plus 1 would be 4. 4 and 1 would be 5. 5 and 1 is 6. 6 plus 1 is 7. If the first roll is a 1 and the second one is a 2, this would be 3. 2 and 2 would be 4. 3 plus 2 is 5. 6, 7, and 8. 1 and 3 is 4. 2 and 3 is 5. 3 and 3 is 6. 4 and 3 is 7. 5 and 3 is 8. 6 and 3 is 9. Notice a pattern yet? We're counting up, starting at a higher number each time. So let's do that. 5, 6, 7, 8, 9, 10. Check your answers once in a while just to make sure we're on. Yep, 6 plus 4 is 10. Then we have 6, 7, 8, 9, 10, 11. And then 7, 8, 9, 10, 11, 12. So now we're looking at our theoretical probability. So let's use our dividing line here. On the bottom is a total number of equally likely outcomes. It looks like we have a total number of 36 squares, meaning that there's 36 total possibilities for these numbers to roll. The first roll could be 1 through 6. The second roll could be 1 through 6. Multiply those together, that gives you 36. So the total number of outcomes is 36. How many outcomes are the ones that we want? Well, we want them to equal 5, the sum of them. So here's one where it equals 5. Here's another one. Here's another one. And here's another one. That's all I see. So that means that there's 4 ways that our event can occur. 4 over 36. These both can be simplified into 1 over 9. And this would be the theoretical probability of us rolling 2 number cubes and getting 5. 4 out of 36 chance or a 1 out of 9 chance.